Yeah, so essentially, the task that we are trying to do here is the summarization and extraction of information from, let's say, a data repository, or let's say a bunch of documents we have. So this task sounds rather similar, and it is actually similar, simple too. But with the LLMs, what we are trying to do is that we are trying to automate it. Uh, without the LLMs, there have been several approaches which use natural language-based techniques, which are often not. So the classical approaches don't actually understood the material that well. They just summarize or produce the summarized versions based on certain statistics. But with the LLMs, what we're trying to do is that we are trying to create a framework which can actually think about the provided material and then produce the summarized documents. So today I will show this for three levels basically. Like the first one is the very basic example. So what I will do is that I will just use either Google's Gemini or OpenAI's ChatGPT and just feed. Let's say I have some article and we can just feed either to Gemini or ChatGPT and just prompt it to produce a summary of that article. So that's the most basic application that can be thought of. Then we can have sort of intermediate level stuff. So here what we will do is that we will make an LLM chain using LangChain and an LLM of our choice. So so technically, these two are not too different from the actual summarization standpoint, but this LLM chain is much more versatile from a practical functionality point of view, because this is built in Python, and once the Python interface is there, then we can let's say outsource this service. Like we can provide this service as an API to anyone, or we can integrate it into some existing websites or things of this sort. So this allows the modularization of things once the lang chain comes into picture. And then there's the advanced example, which will be using multi-level summarization. This is also built based on LangChain only, but this is a bit complex. So the core aspect of this advanced summarization is that this can handle theoretically this can handle infinitely long documents as well. So there is no limit to the length of document that we want to feed it, because we split the entire document into smaller chunks, or let's say semantic segments, and then each of those chunks or segments are then summarized. And then the overall supervising agent will produce the final summary based on each of these smaller chunks. Yeah, so this both this the intermediate LLM chain and the multi-level summarization, both these can be since they are built using Python, they can be provided as an API, or we can really simply put up let's say these services on our website or things like that. Essentially, wherever we are allowed to make API calls, we can use this functionality. So let me just show you the first example here. So let's say this article is there, this news article. So this is a classic example of a typical news article on a current political topic. So let's say we have the article, and we have extracted the text of the article. So here the entire text is present. So for the first basic level summarization, what I did is that I used ChatGPT, and very similar vanilla summarization prompt is provided. Just this is the prompt: to summarize the following article, organize the summary to be easily readable, include all major aspects. So this is the summary that it has generated. And the core point is that the summary is not bad at all. This does the job pretty well, and as we instructed it, most of the major aspects have been included in this one. But when we redo the same thing with the LLM, the second version with the LLM chain, so for LLM chain as well, the exact same vanilla prompt is given for summarization. but you can see the difference between the two. So the organization of the summary for the basic one is that even though the points the summary has been provided in point wise fashion, it's not segmented, or the subsections are not provided explicitly. But you can see that with the LLM chain, it has actually provided semantic segments as well. Like these are the segments, like and the answer is organized, the summary is organized within these segments. So,
sorry, Zishan, what was the first one? How is just the previous output that you had? What is the difference, Zishan? What is this one?
yes, so
It's
this
using ChatGPT, okay?
yes, so this is the basic ChatGPT based. So this is the simplest one. Just feed the entire document to ChatGPT or Google Gemini. Just prompt it, just summarize the following article, or with all the prompt that we want to give. So it will produce a typical summary that we can expect from it. And actually, because this article is not too deep, so this is a regular article only. So it's not like it's too deep. So the summarization with the simplest approach is also good enough actually. But what happens is that with the LLM chain, we have the ability to control a few parameters. So for instance, the model. So here I am using the latest GPT-4 Turbo model, and I have control over temperature as well. So with these tweakings, so if the prompt for summarization is the exact same for both the LLM chain and the chat GPT. But due to the more flexibility that we have, you can see that this summary is actually a bit more organized.
Got it, got it. So what exactly is LLM chain here?
Yes, LLM chain is one of the functionalities that we get from LangChain.
Okay.
So it actually allows us to build it's in the name actually, it's just a chain of LLM. So it gives us three things essentially, and a placeholder to put prompt from where we can put what the actual task is that we want to do, and another prompt which is called template. So in this template we can have system messages which are actually the guiding principles for the LLM. So these are also called the instructions. And the third is the LLM itself, the choice of LLM, which LLM we want to use.
Got it. Okay.
So for this particular LLM chain, the prompt that is there, just the two-line prompt, this prompt, they summarize the following article, organize the summary into easily readable, include all major aspects. This is essentially the template. So this is the overall template, and in the placeholder, I fed this original text which needs to be summarized. So the first two things are there, and the third one is the model selection. So I chose GPT-4 Turbo. So these three things, when fed to the LLM chain, it produced this summary. Yep. So essentially, the major point here is that because of the wide variety of abilities that we have, obviously we don't have control over which model we are using in the simple Gemini or Chat GPT. So here we can have the control over model. Also, we can have control over temperature, which actually indicates how creative the model is. A lower temperature would mean that it will be really fact-based. It won't add anything, like any sort of exaggeration or any hallucination will not be there. With a higher temperature, we are essentially telling the model to be creative. So it will do lots. There is a possibility of lots of hallucination with a higher temperature. So it depends on the use case, what we want to do. So
if you're writing
this,
a creative story, for example, then you'd rather use higher temperature, right? So there is a, just for everyone's information, there is a variable that you can set called temperature. I think Dharmik had also mentioned this some time ago. I'm not so sure if it was in the common meeting or not, probably not. But so the temperature varies between 0 and 1, right? Zisha, is that correct?
yes, typically.
typically. And so the more the temperature you give, the like Zishan mentioned, the more creative it gets, right? And if you want really fact-based information, then you would rather have lower temperature, right? So, for example, in news, even though many of the news channels may want to use higher temperature, we would prefer lower temperature. Is that correct, Zishan?
Yes.
Okay, continue.
So actually, there is a way of looking at temperature as well. Like it is thought of as the entropy. So the higher temperature means more randomness. Uh, so obviously, since more randomness is there, so the model will produce things which can be unexpected as well as sometimes. And lower temperature means things are frozen relatively. So it will stick to what is provided to it.
Okay, all right.
So the third approach is the advanced one, the agent with semantic segmentation approach. So uh, actually, since I am not developing this thing actively right now, so there are some teething issues with this. Hence, the summary that this has provided is not as good as I wanted it to be, but it's still better than both the previous two. So we can see that the output provided by the this is the output provided. I'm just showing the output first. So this is the output provided by the agent, the advanced segmentation based agent. So one of the things that is visible is that it is less organized than the LLM chain because it has not provided separate segment information. But one thing is there that this summary has retained the most amount of information. So, for instance, some of the particular details which were actually originally mentioned in the news article were omitted in both the chat GPT also omitted it and the LLM chain also omitted it for some reason. But this approach with the agent, this actually retained those information. So, for instance, one of that is so this article is essentially talking about the relation between Hungary and Sweden. So Hungary has essentially allowed Sweden to join NATO. So one of the facts is that now that Hungary has sort of shaken hands with Sweden, so it is going to buy some Jas Gripen fighters from it, fighter planes. So we can see that the exact details are also retained in this one. Hungary will purchase XYZ number of Jas Gripens. And if we look at these two summaries, so these did not retain it, even though we did not explicitly say anything about this sort of thing, whether to include or not include. So, so this is the summary which is produced by the agent. So, how does this agent work? We can have a quick look at this thing first. Yeah, so as I yeah, so the overall idea here is that just wait a minute. I don't have a picture for it. Anyways, so the overall idea is that let's say we are provided with an entire article, or let's say whatever the documentation, code, report, whatever it is there, we are provided with it. So the approach here with the agent is that firstly we will we will create smaller chunks of the entire document. And these chunks can be either arbitrary. We can either divide the entire document into fixed words or fixed length smaller pieces, or we can have semantic segmentation that based on we can again use an LLM or a BERT type model, and based on these models we can have topic wise division of the entire document. So currently I'm using the semantic segmentation based chunking. So so this is the output of the chunking actually. So it shows that these are the following segments that LLM has found in the entire document. So it actually found 5 separate topics in the entire article. So these are our 5 segments. And now what we do is that uh, each of these segments is fed to an LLM chain. So the agent controls two things: one, segmenting tool and one LLM chain. So the actual summary is being done by an LLM chain only, which was our second method. But it is not doing the summarization for the entire document. It is doing it just for one particular segment at a time. So the first chunk is provided, here we can see the first chunk is provided to the tool, an LLM chain, and the summary for this chain, for this segment is produced. Again, the second segment is provided to the summarization chain, and it produces a summary for this one. Similarly, this is repeated for all the chunks. Finally, what happens is that the overall supervising agent, it stitches together all these smaller pieces and produces the final answer, which we can see here. This is how this agent-based system works essentially. So this example was rather simple because obviously it's just one piece of article, so there is not much to do here. Even the length is really small. But where the agent and this approach really shines is that when, let's say, we have a really long document. So for instance, the document that I created for the e-commerce chatbot, it had more than 200 pages worth of information. So if we want to summarize or create a report of that thing, obviously, if we take a look at all three approaches, so things which are really long, so basic Google Gemini or Chat GPT doesn't even have that long of a context window, so we cannot even feed those. So this is straight thrown out of the window. So then we have the LLM chain. LLM chain can do summarization of these really long stuff if given the model that we are choosing has enough context window. But here as well, like it's only the most capable of the LLMs which have some significant context window. But by context window, I mean how many words it can process at a time. So there's a hard limit of this for each model. So even for many of the LLMs from really good companies like Cohere and all, they have really small context windows of only 8,000 words. Actually, it is 8,000 tokens, but one token roughly corresponds to one word. So like if the document exceeds 8,000, or let's say whatever is the token limit, then even this LLM chain will not be of that much use. And in fact, even if the context window is that big, there is a high chance that if we, let's say, feed a document which has, let's say, 20,000 words, there are high chances that because only one LLM is doing the thinking, it will miss out on a large number of relevant and important stuff. And it may disproportionately give attention to some bits of information that may not necessarily be that important. And it's essentially like we are leaving a lot on the table for the LLM, which may not be necessarily the best of things to do. So the best advantage of the advanced approach is that because the summarization of each of the smaller pieces is happening at a time, that issue is not going to happen ever, that we are running out of context window. So even if, let's say, we have 100,000 words in our document, we can just chunk it out into smaller chunks of 4,000 words or 8,000 words, whatever is the limit of our LLM. And then we can use the agent, just feed all of them to the agent, and each will be individually summarized by the agent, and finally pieced together. Another advantage of agent is the attention span issue that I explained for LLM chain. So the issue that the agent, so since we are feeding all the smaller segments separately to the agent, it is going to put obviously it's going to put attention to all of these segments, and it is upon we can prompt it to essentially pass through like which topic to put more focus on and which not to focus on. So we are not leaving all that much on the table for the LLM itself in the advanced approach, because we are feeding it manageable chunks of information at a time. So, so these are some of the pros and cons of these approaches. I have another example. The example I showed was a news article. So that is a popular use case. Another one can be is that in the code related domain, we can have so this is a popular issue. The documentations are really long and numerous. So for instance, the LangChain's own document on the agent stuff, it has God knows how many pages. So if we want to summarize or produce a sort of summary for this one, it is really easily going to fall out of the context window of one particular LLM. So it's not possible to feed entirety of this thing to one particular LLM. So we can see that inside agent, some documents are there for quick start concept, and within that one there are several agent types, then separate how to and tools. So there are too many pages here. So I actually chose 7 of them for this demonstration. So these are the contents that were scraped from these 7 pages. You can see that we are on page 5. I think 7 of these have taken more than 20 pages. So if you want to summarize this thing, we can see like what's the performance of these systems.